with swarming characteristics. The proliferation of fake news in social media platforms pose a serious threat to the society, including misinformation, manipulation of public opinion, and so on. The challenger is distinguish between authentic and fake news has become difficult due to the appearance of text and image generation techniques, leading to a growth in need for machine learning algorithms that can effectively detecting and combat fake news. Our target of the research is to develop and present FakeSwarm, a novel fake news identification system that leverages the swarming characteristics of fake news. By incorporating swarm features such as principal component analysis, metric presentation, and clustering for position encoding, the system aims to improve the accuracy of fake news detection. We did our work at a real-world news dataset. It has a long period of time for collection and has 10,000 of real and fake news, including its titles, bodies of the news, and the characters of the news. This is the architecture of our systems. It's a fake news detection system leveraging the swarming characteristics of news to improve the detection accuracy. It takes the body text of the news as input data and predicts whether the news is fake or not. The approach leverages the concept of swarming, which refers to the tendency of fake news to spreading quickly and widely across online platforms. A swarm is a group of fake news with similar topics that occurs in a concentrated period of time. The first stage is transforming the raw news to text embedding. We do some data preprocessing. For example, removing text source information in the news. Then we do word embedding. It's a technique in NLP that captures the semantic meaning of words by creating numerical vectors. It improves NLP models by enabling better understanding of text and enhancing performance on various tasks. FakeSwarm utilizes word-to-vec as the word embedding algorithm, extracting word embedding from the real dataset to obtain comprehensive semantic information. We applied average pooling to generate fixed-size text embedding for news, capturing the average features values across all words in each article. The first swarming characteristics is the principal components. Principal component analysis is a technique used in FakeSwarm, our system, to reduce the dimensionality of data while retaining essential information. The data refers to the text embedding. By calculating the principal component analysis algorithm creates principal embedding. It's a lower dimensional representation. This approach improves the detection accuracy of fake news by reducing the distance between data points in the same swarm. The evaluation system confirmed the effectiveness of the principal embedding, enhancing the performance of FakeSwarm, the fake news detection system, and we will discuss that later. And the second swarming characteristics is the metric information. Our system leverages contrastive learning to create metric embedding. By adjusting distance between instances with the same swarm, and the increasing distance between different labels. Contrastive learning enhances the representation of raw text embeddings. Our system adopts multi-layer perceptron as the embedding network, optimizing parameters using contrastive learning. The loss function incorporates a distance function and labels information with the margin hyperparameters controlling the distance between different classes. Through these techniques, our system achieves improved fake news detection by optimizing the distance with the metric embedding. And the third swarming characteristics is about the position compared to the clustering. In our system, addressing the challenge of mirroring the relationship between news and swarm is crucial. To tackle this problem, we applied the DBScan clustering algorithm. It's capable of identifying clustering of various shapes and sizes without the need to specify the number of clusters manually. Additionally, our system incorporates positional features through the positional embedding, which include swarm identification and the distance from the news embedding to each one cluster center. The solution improves the understanding of the relationship between news and swarms, enhancing the effectiveness of the fake news detection result. To evaluate our system, we firstly contrast the ground truth based on the real-world dataset. We split the erode instance into training and testing sets. The performance was assessed use accuracy and F1 score metrics, mirroring overall classification, correctness, and combining precision and recall. This table shows the performance of individual swarm embedding. We can see the metric embedding outperforms text embedding, and the principal embedding also performs very well. But the positional embedding is not so good, but we will see the improvement in the next experiment. Then we observe a difference after the combination of the swarming embedding and the raw text embedding. We observed the concentrating text with any swarm embedding result a significant performance improvement. Additionally, the best performance was achieved by combining text embedding with 3 types of swarming embedding. Notably, even the positional embedding showed improved performance when combined with text embedding, even it has the not so good performance when used individually. These findings highlight the effectiveness of incorporating multiple types embedding to enhance fake news detection, especially effectiveness of swarming embeddings. And we also compared with previous works. Our system demonstrates superior performance compared with the previous works in fake news detection. Text embedding alone in FakeSwarm outperformed the best classifier employed by the previous work. When combined with swarming embedding, our system achieved even higher accuracy, showcasing its effectiveness in detection fake news. We also stimulate the fake news detection process in a production environment using streaming format training and testing dataset. By incorporating swarm embeddings, our system achieves earlier stage accuracy improvement and maintains stable performance over time, as shown in the two figures. The effectiveness of swarming embedding in detecting fake news remains robust even after reducing the data for training. So let we make a conclusion. Our system, FakeSwarm, is a novel fake news detection identification system that leverages swarming characteristics for enhanced detection accuracy. Combining three types of swarm features, it achieves impressive F1 score and accuracy of over 97%, making it state-of-the-art. The online learning pipeline evaluate its robust performance, particularly in early stage with limited training data. FakeSwarm provides a fresh perspective and approach to fake news detection, highlighting the importance of swarming characteristics and encouraging further research in this area. If you have any problems, you can find me in this email address. Thank you for listening.